So I'll be presenting a portion of the research that we've been conducting in RA1 together with Stacy Marcella and our team of graduate students and postdocs. As you can see, we have a large team of people working on this. Our main challenge is really to enhance the response efficiency to mitigate active shooter incidents outcomes at soft targets. And we focus mainly on schools, but we're also looking to stadiums and other venues. The key element of what we've been working on is to account for psychological and social influence factors. This is important. Soft targets threats are increasing. Since 2020, there have been an average of over 250 a year at schools. Before 2020, there was no year with more than 125. But this isn't just limited to schools. Soft targets, as you know, can occur at shopping malls, stadiums, and just a variety of other places, hospitals, public buildings. But schools are particularly sensitive for a variety of reasons, as we know. You may see a few of these graphs today from myself and other speakers, but as you can see, over time, school shooting incidents have increased dramatically. And in terms of victims, both fatal and wounded, so it's become a more deadly and a more serious problem. So this is an overall picture of the approach that we've been taking that combines both behavioral simulation experiments with agent-based modeling. And the idea here is to collect behavioral data in an immersive virtual environment from human subjects, and we systematically vary components of that environment, particularly with respect to how people are interacting with each other and the kinds of psychological cognitive elements of the situation, such as uncertainty and ambiguity. We use those behavioral results to inform our agent-based models. Agent-based models have been around a long time, but often they're based on somewhat arbitrary or theoretical views of how the agents will respond. Our agent-based models are based on the behavioral observations that we make in our experiments. We combine this with a simulation design that allows us to compare different levels of exogenous variables and to actually obtain results to see survivability as a function of all of those various factors. So that's the overview. We focused on whether our agents or whether our subjects are running or hiding. This is part of the FBI Run, Hide, Fight initiative. This is a little complicated, particularly in places like elementary schools or unfamiliar environments where people may not know where to run. And human behavior is variable. People do different things. They may be restricted in certain ways, and they simply just may respond in ways that are very hard to predict. For our research so far, we've ignored the fighting option. This is a last resort in the FBI protocol, and it's something that we haven't tried to attack yet. So just as a disclaimer. So as I mentioned, we use an immersive virtual simulation environment. We ask questions, or I'm going to describe very, very briefly an experiment and an agent-based model that was informed by that experiment that includes research questions regarding how proximal social influence, that is what other people are doing, influences behavior, the threat uncertainty, which we manipulate by the proximity of the shooter, and how these might interact with each other in ways that we would not predict. And then how do participants' emotions change in response to the simulation? So this particular study, as I said, I'll describe briefly, is a 3x3 factorial where we vary what the non-playable characters are doing, whether they're running or hiding or a mixture of that, and the uncertainty of the threat, whether it's high, whether you hear gunshots but can't really tell where the shooter might be, or even if it is a gunshot, medium where they're somewhat close, and then one where the shooter is actually very close and you can see the shooter in the same room that you're in at the beginning. So this is a layout of the school. We partnered with the RD researchers on work that they had done looking at more architectural features. The Unity code that went with this goes way back, like much the software goes through various generations. So we borrowed it from RD researchers who borrowed it from some other people and so on. But this is the layout of the school that was used. Again, this is our 3x3 design, and we did obtain over 500 participants from a platform, prolific.com, and looked at all 9 conditions here. This included, by the way, 37 non-playable characters that people could bump into and observe. So the protocol, people filled out a brief version of the positive and negative affect schedule to measure affect. There were 2 training sessions, both to train people on just controlling their character, and a tour of the school. There was a simulation session where we actually collected data, and then a post measure of the PANIS. This is just a screenshot showing the training where they learned how to move the controller. This is one where they took a tour of the school, and they had to visit 7 different places so that they got a sense of the layout of the school and how to move about. And again, this is a layout of the school and shows in the circles the places that they visited. So they got a pretty good view of the entire school building as they played through this session. And then the simulation session looked something like this, where they started out in the school and they could move about. Here's a situation where everyone, the non-playable characters are exiting, they're running out at the sound of the gunshot, and one where they're hiding instead. So what did we find? We found that participants indicated that there was a decrease in positive affect and an increase in negative affect. We take this to mean basically that the simulation was pretty realistic. That is, that they were engaged and they were immersed in the situation. The percentage of participants who evacuated, and this was a surprise to us, was the same whether they had ever received training on school shootings or not. Some had not. We thought training might have changed that percentage. We thought maybe a higher percentage would have gotten out, but that didn't seem to be the case. It could be that it's particular to a particular location or building, or it could simply mean that the training was not generalizable. We found that manipulating social influence had a large effect on people. And by that, I mean when others are running, our subjects are running, when they're hiding. It was most potent, though, in the high and the medium threat uncertainty conditions. When uncertainty was low, it had less of an effect. That is, when the shooter was right there in the same room. About 40% believe that the NPCs influenced their behavior, because we asked them this afterwards. And so participants are generally aware of their chosen behavior and whether or not others around them are influencing their behavior. Most of the participants evacuated before the simulation timed out. You see that about 15% more participants ran away when the threat uncertainty was low. And male participants were more likely to run away when the NPCs attempt to run away. So they were more influenced by what others around them were doing than our female participants were. So let's move on to the ABM. As I mentioned, we use these results to inform the ABM.
What is ABM?
This is agent-based model, sorry. And the idea is that humans really don't act based on any known algorithm. We use the data from the experiments to inform, and in particular, we use the reaction time and speed in our model, conditional on what others are doing. So I'm going to go quickly through this. This paper is available. It was published as a proceedings paper, but it was constructed in NetLogo. We've now gone and expanded this to other platforms. We use the same layout of the school, and we had three types of agents: students, shooter, and law enforcement. And it is somewhat primitive. As I said, we're expanding this, but the goal is to demonstrate how we can inform an agent-based model and create an extremely realistic simulation eventually. This one is not that realistic. This is a school layout. As you can see, our agents, there's 60 of them, begin in the cafeteria. And when they hear the shot, they start to move. I'm not going to go through all the details of the model. This is details of how we inform the model using probability distributions based on the behavioral data that we obtained in the experiment. And you can see the shooter behavior is fairly standard. They move at about a quarter of a yard per second with a weapon always ready unless they're reloading. They follow the same path as a shooter from the behavioral experience, unless they're pursuing another agent. They enter through the front entrance always, not through another place, and go directly to the cafeteria. And basically, they shoot the closest target within 30 yards. And we did vary some exogenous variables in terms of the magazine capacity and the accuracy of the shooter. And we looked at the results as a function of that. There's a pause for 3 seconds to reload, and they can shoot 1 shot per second. So the law enforcement always enter from the east exit. This is further away. The dispatch time varies, as you can see, 1, 3, or 5 minutes. This is because they're considered to be the resource officers that are already on campus. And they move a little faster than the shooter, 0.75 yards per second, and they're set to shoot the shooter when they're within 30 yards. So this is the layout of the school, and it shows the path of the law enforcement in blue, the shooter in red, and possible escape paths for the students in green. This is the model, and you can see an example where the shooter comes in and the students exit. Law enforcement comes in very quickly from the right. This is an overall of the simulation design. We had 81,000 simulations, as you can see, and I'm going to skip over the details of this and get directly to some of the results. Basically, we saw that whether the social influence factor had a main effect on how people survived the simulation, and we found one very interesting result, which was that agents in the mixed condition were least likely to become casualties. This was somewhat surprising. It turns out that if everybody runs, you have a bottleneck, and if people hide, then that sets up targets for the shooter. But in a mixed condition, there's actually the greatest survivability, and that's a result we didn't expect. I suspect the evolutionary psychologists would find that very interesting.
So
we also found
by mixed, you mean some run, some hide?
Yes, exactly. We also found that dispatch time and shot accuracy had the expected relationships with the number of casualties. And again, this is somewhat specific to this particular simulation. What we envision is actually the capability of being able to take any soft target venue and being able to produce an agent-based model that would allow them to model different strategies based on the simulation results that they get. So our main conclusion is that we can inform agent-based models from behavioral data. We found that the student behavior really did depend upon social influence factors and psychological factors such as ambiguity and uncertainty. And we expect to expand these results with more behavioral data and somewhat more realistic agent-based modeling software. So quickly to wrap up, some of the milestones I've already mentioned. The technological advancement was this agent-based model of the school constructed in that logo. Several products generated included journal articles published, proceedings papers published, conference presentations, and various manuscripts under review. We've partnered with both RD researchers and RC researchers, as well as people outside of Century, including the Coast Guard and the stadium people at Gillette. And finally, my last slide, why is this work relevant? For all the reasons we've talked about so far, soft targets are increasing, attacks are increasing, casualties are certainly sensitive to the reactions of those targeted, and it's important to account for these psychological and social influence factors because it improves planning effectiveness. And we feel that this behavioral virtual environment experiments and the ABM simulations will improve training for and communication during these active shooter incidents. And we have a number of things planned for the coming year, both the rest of this year and next year. Additionally, behavioral experiments with larger venues, constructing ABMs that explicitly model social contagion effects more realistically in these venues, and conducting additional ABM simulations that are informed by the behavioral experiments. So with that, I will turn it over to the next speaker.
So, Richard, before you do, just quickly for the audience, define what you mean by an agent-based model.
Yes, and so an agent-based model is a model, in fact, I showed you a picture of one earlier, in which we have agents whose behavior is very simply defined, and the insight that's gained from it is the emergent behavior of the whole system that we see. So this is a software program. As I mentioned, we used a common one called NetLogo. This is something that we actually envision being able to train students to be able to use, even undergraduates or high school students at some point. I know we talked to Desiree about that. And for our purposes, though, we're able to recreate this where we have the ability to manipulate different parameters in the model and see how it influences or impacts the survivability of our students and staff in the school.
So each figure in that diagram is a user, a real human user, who is reacting to the situation. Is that right?
Exactly. Exactly.
Okay, so it's not a cartoon of, sort of simulated people. These are real people that are reacting to what they feel is a real situation.
Exactly. And their movement is guided, as I said, by the behavioral experiments that we did probabilistically.
So